This is part 3 of trigonometry, the last part, where students understand how to use trigonometric ratio to find the unknown angle measures of a right triangle, the unknown side's length, and student will be introduced to the concept of inverse. Please review previous instructional video if you're not sure how to identify the size or how to pick the right formulas. In part 3, we will move on to solve the equation. T3 work. We are going to show you how to answer these practice problems. Don't forget to check and correct your answer. This is a very important process so that we can find out what kind of mistakes we make. Part 2, find the length of the side marked X. Leave all the answers to one decimal place. I want to underline this. They only want one decimal place. That's the 10th THS at the end. One number after the decimal. If it's two number, we call it the 100th THS at the end. 1000, three number after the decimal, and so on. Diagrams is not to scale. Hint, label each side first. Diagram is not to scale. What that means is that even though this triangle is not marked with a right angle, you should know that that is the right angle. That's what it looked like, a 90 degree. That is actually a 90 degree. If that's the 90 degree, the opposite to that angle, this side, is called the hypotenuse. And we have nothing on that side. No information. Not even the x variable. X is the side length for this short side. I know it's short because it's across from this angle that is missing. We have 67 to be this one. The missing angle is around 23 degree because 23 plus 67 is 90 degree. The sum of the three angles in the triangle. So that's how I know this is a short side. Remember, the side and the angle opposite to it are related to each other in a triangle. I have 67 degree here. The bigger angle, the opposite side, which is side 15, that is the longer side. So short side is the x, long side is the 15, and the longest side is the hypotenuse. Label these sides. The side that make the angle here is called adjacent. 15 is the side opposite because it's the only side that doesn't make the angle theta or angle 67. Which trig formulas has the letter O and the letter A, or AOOA? So Katoa, our favorite Indian friend, blah, 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 blah. If you forgot, go ahead and review the instructional video called Which Trig, where I show you in details how to pick the correct formulas. I'm going to just locate the formula that has OA or AO.
The first one, I can go ahead and cross it out because the SOH has the hypotenuse information. But our problem here has nothing on hypotenuse, so I cannot use SOH. I cross it out. Same thing with CAH. The hypotenuse, we have nothing on the hypotenuse. And therefore, we're not going to select this formula that has hypotenuse in. I cross it out.
The only one that has the O and the A, or A and O, is the last one. TOA has tangent formulas, and it has the letter A and the letter O, which stand for side, adjacent, and opposite. I'm going to go ahead and use this. After I have selected which trig tool to use, which is the tangent, and most of these problems are going to be tangent. Remember earlier practice, we practice a lot on sine and cosine. So this one is the one focused mostly on tangent. You are going to use the tangent formulas. It start with, I have put the work on the left side, which is right under my bubble. Tangent of the theta angle, the reference angle, equal the opposite side divided by the adjacent side. I hope you picked up the clue. TOA in that order.
Start with tangent. Tangent theta, we substitute for 67 degree, which is given to us 67 degree. Equal, opposite side is substitute by the number 15. It is given in our figure. Divide by adjacent, and adjacent is substitute by the letter x. for adjacent side is given in our figure.
Tangent 67 degree equal 15 divided by x. This is my equation. Tangent 67 degree, I can look it up and replace that with a trig table values, but we will go ahead and leave that for later. I see that I have a fraction on the right hand side, 15 divided by x. I want to go ahead and get rid of the denominator, so I don't have a fraction anymore. And the way that I get rid of the denominator is doing the inverse. 15 is dividing x, dividing, what is the opposite or inverse operations? Multiply the exact denominator to get rid of it, and that happened to be x. I do that to both sides. I rewrite the equation, the exact same equation, and multiply x to both sides, written in the black letter x here and on the left side. What I will do then is be able to cancel out the x on the right hand side and the denominator, and we no longer have any denominator. X times tangent 67 equal 15, and there is still something with the x on the left hand side. I'm not done yet. I need to get x by itself, eliminate everything with it. So sign in between, the x is multiplying the tangent of 67. Divide by tangent of 67 on both sides, and I can get rid of the tangent with the x on the left side. To isolate the x, I divide both sides by the exact same tangent 67. I can go ahead and cancel it out like that. The left hand side, tangent 67 now is on the right hand side, and we end up with x equal 15 divided by tangent of 67. Now I'm going to go ahead and look up this value. What is tangent of 67? And then I'm going to calculate what is 15 dividing that number. You have two ways to look up tangent 67. The first way is using the trig table. Tangent of 67, the degree start from 46 here. I go down all the way to 67. I go across to tangent, and the table values I see is 2.3. There is a quicker way where you can get the trig tables values, and that is using your scientific calculators on your phone, or you can use the online scientific calculator, but you have to be careful. I just open a new tab, I type in scientific calculator, hit enter. I get my first calculator, make sure that the degree is selected, then you can use tangent 67, close the parenthesis or just hit enter, 2.355. Double check with the trig table values first on a couple of them and make sure that you're on the correct mode, the degree mode. That's the number that we are getting. We round it to the thousand place, 3 number after the decimal. And the A is on the right hand side, that's why we round up and we get 2.356. I run out of room on the left, so I put the arrow, and we are going to put the final answers to the right of these problems. We have the 15 divided by 2.356. I can just use a regular calculator. Strongly recommend that you have on hand a regular calculator or a scientific calculator. My answers, 6 point, a lot of number behind the decimal, but remember the problems that we need to round it to 1 decimal place. So we only need 6.3, and I'm looking at the number to the right of that. We're rounding it to the 10th place, and the number to the right of the 3 is 5 or higher. I round up and I add 1 to the 3. I will get 6.4 as my answers, and that's the answer that you see in the box, 6.4. Now there is one very last step that I need to point out. You need to check for the reasonableness of the answers. And what do I mean by reasonableness? I am looking for the short side. The short side, if you remember, we put 6.4. 6.4, it makes sense that is shorter than 15. If my answer is 15.4 or any number higher than 15, it doesn't make sense because that's supposed to be the shorter side. Shorter side doesn't have a number bigger than 15, the opposite side, the longer side. And so that's what I mean by check for the reasonableness of the answers, that the answer makes sense. If you have too small of a number like 0.49 something, put it in wrong, or maybe you misread the chart, or maybe you divide it but the calculator make the mistakes when you put it in, the order matters. So be careful. The number too small doesn't work. The number higher than the longer side doesn't work. And if, let's say, we're looking for the adjacent or opposite side, and we're given the hypotenuse, then the answer has to be smaller than the longest side, the hypotenuse given. And that's how we can check for the reasonableness of the answers. Remember these problems from choosing a trig tool in instructional video part 2. We will show you how to solve the trig problem, the entire process at this time. Last time we boxed the equation to solve, and this time we're using the equation to show you how to solve the entire problems. Let's tick off these boxes so that we can continue in solving questions. In letter A, you are seeing the equation start with the trig tool called sine. So sine of 28 degree equals x over 19. I see the denominator of 19, and that's the first thing that I want to get rid of, the denominator. What I want to do is then the inverse, and I will multiply both sides by exactly 19, and that way I can get rid of that. I put the box around the letter A so that you know that we're working on these problems. I write the multiplication of 19 on both sides. This will help me get rid of the denominator on the right side. The number 19 is crossed out. I only have x left. And all I need to do is look up the values for sine of 28 using the chart or using the scientific calculator. Multiply that number by 19, and I'm done for this problem. Open scientific calculator, select degree.
Sine 28 equal, and then use this number to multiply 19. But don't forget, if you're using the scientific calculator on your phone or online, make sure that you check this value with your
trig chart first and make sure that you're getting the correct values before you moved on. Sometimes we might get the radian and it will be the wrong answers. So 0.469, and we can multiply it by 19, and then we can round it off. When we don't have any indication of what decimal number place we have to get, we can just use the hundred. 8.91, but we're going to round up. 8.92 is the final answer. Checking for the reasonableness of the answers. 8.92 is the answer I have written. For the x side, the x side is the short side reflecting this smaller angle, 28 degree. Short side is 8.9 or around almost 9, which is still shorter than the hypotenuse given with number 19. So that makes sense. If I don't get a too small number like 0.89 something, that makes sense. This one is checked. Next problem, letter B. We are looking at the trig tool tangent, and to be tangent of 45 degree equal 8 divided by x. The denominator is x. I'm going to get rid of that first. And I'm going to get rid of the denominator so I can just work with our denominator. Rewriting the equation, I'm going to go ahead and multiply x to both sides using the black pen. The denominator will get canceled out on the right hand side. I ran out of room to write the next step, so I put the arrow up and we will try to squeeze it into this space here. We are rewriting the equation, simplified from canceling out x on the right hand side. I'm left with x times tangent 45 on the left equal 8 on the right. And what I will do is get the x by itself And this is multiplying when there's nothing in between or there's parentheses, so it's multiplying. We will go ahead and do the inverse and divide both sides by what's with x. It's tangent 45. So let's go ahead and divide both sides by tangent 45. After I divide both sides by tangent 45, I will get tangent cancel out of the left hand side. X is now by itself, and I just need to simplify it and find the answer for the right hand side. That give me 1, and 1 multiply anything is itself. 8 divided by 1, I get 8. The answer is 8. Let's make sure that our answer makes sense. So A is X, it's going to be right here, and the other side is also 8. So I have an isosceles right triangle. You remember we studied the special right triangle. There are 2 special types, 30, 60, 90 and 45, 45, 90. If we remember that, we didn't have to go through this trig process and solved it. If we just use the special ratio we learned, 1 square root of 2 for special right triangle 45 degree. What that means is that this side and this side are congruent to each other. 1 is square root of 2. The last problem that we're working on this page, letter C, we are using the trig tool called cosine, C-A-H, and you can see the equation we have written before. Cosine of 61 degree equal 18 over x. The denominator is the letter x. I'm going to get rid of the denominator first so I don't have to work with denominators and no more fraction in the next step. I multiply by exactly that denominator x onto both sides to get rid of the one on the right hand side. We will go ahead and use red to write it in this time so you can see the contrast. I'm going to cancel out the x on the right hand side, and I will end up with the equation x times cosine 61 on the left. On the right, I only have 18 left.
Go ahead and write it under here because we don't have room on the top anymore.
We have continued under this space, and what I have on the left with the x is cosine of 61. We're doing the inverse operation of cosine times x, and that would be dividing by exactly that, cosine of 61. And we do it to both sides. Dividing cosine of 61 to both sides, I will be able to cancel out the cosine of 61 on the left. And now x is by itself. We're almost there. We just need to simplify the right hand side and we're done. I am going to find 18 dividing by cosine of 61. Zero point and a lot of number behind the decimal. How many number do I need to get? Well, the more you get, the more accurate your answer will be. But normally, if we don't have any preferred numbers, we will just use the thousand place, 0.484. And looking to the number on the right, I get an 8 right behind the 4. So my 4 will add 1. I round it up. My answer will be 0.485.
Also divide 18. Dividing by 0.485. Enter to get the answers, 37.11.
There's so many box and circle on this page. I decided to just highlight my answers. And the answer is 37.11. You will be able to check the reasonableness of the answer if we substitute it in. And you can see this is the side that we have with x that we're looking for. Hypotenuse. My answer needs to be longer than any given side, opposite or adjacent. And 37, the number is bigger than 18. So that's how we can check the reasonableness of the answers. Pause and try. We went over which trig and solve for the missing side. I just realized that I don't have any example on solving for the missing angle. So I'm going to go ahead and show you one last example. We went through the whole model problems and we actually went through several examples to show you the entire process on solving using the trig ratio, sine, cosine, or tangent. Remember the very last step? which is not least. Last but not least, step number 9 is to check for reasonableness. And we're just checking to see if the answer makes sense. If the answer is too small, like 0.586 something, then it doesn't make sense. When the answer is comparing the side length, hypotenuse, and you're looking for a shorter side, and the answer is longer than the hypotenuse, it doesn't make sense. So let's go ahead and see our last example, looking for an angle. And we also call this one inverse trig. A few terms to know before we go to the inverse trig example and solve it. For example, below the formula SOHCAHTOA, we show you, we see the tree, and right below that we have the watchtower over here with the airplane too. There are a few terms I want you to know. The last line on this page is called angle of depression. Angle of depression is when you're looking down. Angle of elevation is when you are talking about the angle when you're looking up at something. The bottom right hand, we have the person looking up at the tree. That's called the angle of elevation because we're looking up. And then on the bottom left hand, we have the watchtower in black and white. And from the watchtower, we are watching the boat. So that's the angle of depression because we're looking down. Here is an example of the inverse trig, and you know how we love in math to go back and forth. This time we're giving you the sides, we're asking for the angle. Before this example, you have seen where we give you an angle, we give you a side, we ask you for the other side. It could be an opposite, adjacent, or a hypotenuse side. Here we're going the backward way. We're giving you the sides and we're asking you for the angles. And you can imagine using trigonometry in finding the height of a building. Now maybe where is that missile or airplane? If we're looking up at this angle, we know the angle, and we know one of the side. Then we can just locate how far it is. We can probably stand in the rivers or and measure its depth. We can do many things. Find the height of a very tall tree or mountain without having to climb on top of the mountain and drop a very, very long rope to touch the ground and measure its length. We can actually use trigonometry to find it. And that is why studying trigonometry is very important for archaeologists, many career field, construction engineer, and many more. Let's review the symbol for trigonometry. We have three symbols. The inverse of sine. You can see it has a negative one like an exponent, but that is not an exponent. It's just a symbol to say that's the inverse of sine. The cosine with the negative one symbol again, it tells you that's the inverse of cosine. And you can see the letter x is just like theta. Instead of putting theta, I can call it, x, y, or any letter A, B, C. Tangent, the inverse of tangent with the negative one, just tell you, it's not an exponent by the way, but it's just a symbol to tell you the inverse of tangent. And the x here is like the angle theta. It can be replaced by any letters, or it can even be replaced by the measure of the angle itself. So we're looking for the angle, and that's why the angle theta is now called x, because usually we're looking for x. The angle is actually angle A, and to write this correctly, let's go ahead and start with the question first. Find A to the nearest degree not drawn to scale. So this is a right triangle and it's not drawn to scale. Which one is the longest side? Well, it looked like 19. So it looked like this is my right angle and this is my hypotenuse. Hypotenuse, my longest side is 19. Now my side that make that angle A is going to be called adjacent, the number 9. If you're not sure on how to identify and label the side, please watch Trig T1, T2. The last side that is not marked yet is the opposite side. The only side that does not make the angle A. Looking for the angle, and we only need 2 of the side, and I'm given 3, so I can actually use sine, cosine, or tangent to write the equations. I'm going to just go ahead and pick on sine, but you can also use cosine or tangent to find the angle missing. To start off, I will go ahead and use sine with the simple -1 on top. If you are using sine, remember SOHCAHTOA? SOH. I need the opposite side and I need the hypotenuse. I don't need any other side. Only opposite and hypotenuse.
Substitute in the side that we know. Opposite side is going to be 16, so I will go ahead and write the number 16 in. The hypotenuse is given to be 19, so I will go ahead and write 16 over 19.
All I have to do to find the angle A is take number 16 divided by 19. We get 0.842 and a lot of number behind the decimal. Just to be safe, I use and round the decimal to the thousandth place. So 0.842, and the number behind it is 1, so everything stays the same, 0.842. You may then use the trig table chart or the scientific calculator to find the angle. I am looking not at the degree because I don't know that. I'm looking for the degree. So what I will do is I will look down the sine column until I can locate 0.842. And looking from the left, I have a very low number on the last line, 0.7, and I'm looking for 0.842. So I'll go ahead and go to the right side of the blue line, looking down the sine columns only, because remember, that's the formula that we started with. So sine 0.71 going all the way down to 0.842. Now, I don't have the number 0.842. What do? I have 0.848. That's close. A closer one, 0.838. So between these two numbers, I know my answer is between 57 degree or 58. Which one is a better answer? Well, that's hard to decide, right? What if we round up to the 100 place, 0.84, and because the number 2, we are going to keep the number 0.84. And right here, if you are looking at this one, 58 degree, I will get 0.85 if I keep the 100 place. But 57 degree, 0.83, and I round up to be 4 because the number to the right of it is 8. This is how I can decide which one between 57 or 58 degree. The closer answers would be 0.84 or 0.83867, and when we round up to the 100 place, we get 0.84, 57 degree. And I just look backward to the degree, go back to the left side under the degree side, and then look up the angle. Angle answer is 57 degree. Another way we can do is we can use the scientific calculator. I will pull up one online. You can use Desmos.com. It has a very nice scientific calculator, or even your cell phone. Just remember it's in degree first. I am using the inverse function. Scientific calculator or some smartphone will say second function, and then you can find the inverse key. Some will say more function. You click on the more function, you will get the inverse key. On this one online, the first one that I see, I am seeing the INV. I think that's the inverse. So let's click on there. Yay! That's where we get the inverse. You see the -1 exponent on these? Make sure it's selected with the degree, arc sign. Okay, that's how it looks for the inverse function. And we are looking for 0.842. Close the parenthesis, hit enter. 57 degree, and we don't need the 0.351 because it mentioned right here find to the nearest degree, so we don't need to get any decimal behind it. 57 is our final answer. We can go ahead and box or circle these answers. In example 2, We are only given two sides, so we're limited in the inverse function we need to find the angle. So anytime we're looking for the angle, you're using the inverse, sine, cosine, or tangent. It depends on the information, the side given to you. Let's go ahead and label these sides. We are labeled with the angle theta. We're missing that angle and we're looking for that. In example 2, find angle theta to the nearest degree. We are just given two sides, so we will be limited on the inverse trig tool we use in looking for this angle. The 12 is the hypotenuse. What is the tool we need to use that would have the A and the H letter? AHHA from SOHCAHTOA. Pause and try and see if you can find the missing angle. We chose the tool in the middle, the CA, because it has both the letter H and A, or A and H, adjacent and hypotenuse side. I wrote the equation starting with the cosine. It's the inverse cosine because we're looking for angle theta. And theta is missing, so we cannot substitute it with anything except just to leave it like that. Adjacent, I can go ahead and substitute it with the 9. And hypotenuse, I can substitute it with the 12. Let's go ahead and write it in 9 over 12. I will use a calculator. Even if my calculator only have the basic key, it will help. 9 divided by 12, I get 0.75, 0.75, and we're looking down the cos value to find the degree. You can use the trig chart or you can use the scientific calculator. Looking down the trig chart, I am looking for the cos, the middle one, and I'm looking for 0.75. On the right hand side of the blue line, I see it start with 0.69, keep looking down, 0.75. Oh, it's going down, so maybe it's to the left of the blue line. Cosine 0.75 is way down here. I see 0.754 and I'm going to go ahead and stop at 0.754. Now look to the left side and find the degree. I get 41 degree and 41 degree is the answer. So scientific calculator, decimals.com, or just type it in online. 0.75. We will use the inverse, and remember sometimes it has the second function, sometimes it has more function. One of those buttons, we are looking for cosine, and that's what it looked like when I click on that button. 0.75. Enter or equal. What did we do wrong? Remember what I did wrong? I forgot to select degree. So that's why we have that answer. See, when the answer doesn't make sense, 0.7, that's too small to be an angle. Degree, select that first. Let's try it again. We would hit inverse cosine, 0.75, enter. Now that makes more sense, 41.4, but we're going to round it to the nearest degree. So 41 is the answers. I have put the 41 degree in, and let's check for the reasonableness of the answers. 41 degree is this angle and it's less than 90. So that, first of all, that makes sense. If we are looking for the answer and it's 90 something, it's bigger than 90 degree, it doesn't make sense. If it's too small, like 0 point something that we found earlier, that doesn't make sense. Let's have you practice. Have fun. Don't forget to check your answers.